Look at that.
Nice.
Oh. This is the final test on this one for a while because I'm going to start on the final plane. My goal here is to break through the high alpha barrier and get the plane to just stand real still and even hover. What I've got on it now is 3 gyros. Look at the canards on the front. So when the plane senses unwanted pitch movement, the gyros can correct that for me. See the gyro on the rudders? So when it's up doing high alpha and starts to get waggy, the gyros correct that. Same thing with the roll, both with the rear elevons and the ailerons. Stage 1 of this project was finding the right dimensions and hardware as far as the wing area, the aileron configuration, as far as the angles and the proportions and the canards, and basically finding all of the hardware needed to have it physically be able to come up and stand like that, thrust vectoring and all that. Now that took a long time. Now phase 2 is now the programming of the radio, the settings, the gyro settings, the amount of throw, the amount of movement. So that is high alpha up like that. Control surfaces back into the air, stabilizing the airplane. So just like the real plane, it's very tail heavy. Look how in neutral the canards are angled down. Watching the real Su-35 and Su-37, the real planes fly with their canards angled down or their elevators angled down, pushing the nose back down because the planes are so tail heavy, they always want to pitch up, which is great for maneuverability. That way when you want to go up, it's always there. You're not slugging a heavy plane up. So the computers are always keeping the nose down so it doesn't pop up. So the first thing I noticed is that it's much smoother on level flight. It used to kind of slide its tail out when I would make turns. It's just such an aerobatic plane, it's always kind of dancing away.
Yeah.
I can see it wagging a little bit. That's the gyros overcorrecting, so I probably want to dial the gyros down a little bit. But watch high alpha. So let me bring it down a little lower. So it takes that wag away. Look at that. See that? You like that? Look at that. Look at that. And that is with no practice. So I've got one more computer to program, and that's my head. I got to learn how to fly this thing now that it can fly.
Get out of our airspace.
Look at that.
Nice.
Oh.
Somebody was showing
It's a little
off.
too heavy. Okay, so what I've been talking about, I've been trying to sell everybody Metal Gear servos, and that is the reason why. Now a hit like that, I always break the gears, especially with all the thrust vectoring. With this thing being a little bit heavy, I don't have the power anymore to take off, so when I make the final one, it'll be at least a pound lighter, so when I need to jet back out of there, I can, rather than like, look, I'm hovering! Got 2 6x4 props. The entire plane is built around these props. These are the jet props to use, 6x4s. They have the right ratio of thrust and all that kind of stuff. So that's determined the dimensions here, which then therefore is determined the rest of the size of the plane. That's why the plane is this size, because they're built around the entire prop. That's how important props and motors are. That's what we cover in our ebook. There's another commercial for you. So I've got 2 counter-rotating props. So one goes clockwise, one goes counterclockwise. If they both went one way, or if I just had one prop, I would have torque roll. It'd always be trying to unwind the motor and the plane to one side. Phase 1 was getting all the hardware set up, so I had everything there able to do what I wanted to do. I could fly it slow, I could do high alpha, and I could do all the stuff. It's just that the gyro helps smooth all that out for me. So I'm not asking the gyro to do anything that the plane isn't capable of doing. I'm just asking the gyro to do it so much more efficiently than a silly human can. So get it 0 in there. Look at those canards move. Look at it stabilize itself.
Yeah, that's amazing.
All right, I better land this now. So here's the real test, landing a tail-heavy airplane.
Without breaking it.
Look at that. Look at that. Did you see how smooth that was? It just kept it right there. Without it, it's all over the place. I swear, when I first plugged all this into the gyros, it was like in the Terminator movies when they transfer all the power over to the computer for the first time. Like, oh, what's going to happen? It's kind of the same thing. It's like this is completely stabilized and flown by the 3 Elevon mixers and the 3 gyros and the computer settings on this. And so I'm just kind of telling it where I want it to go, and then it's doing all the work. All right, I've unplugged all the gyros. There's a high chance this is gonna result in a crash, but you know what? With flight testing, it's good to go past your envelope. It's good to not only know what your plane is capable of doing, but what it's capable of not doing. Crashes and successes are both equally good because they're both giving you information. This is gonna tell me how much the gyros are actually helping out.
Whoa.
Wow! This is a handful to fly. So you can see what I mean, how the plane will still fly, it's just that the gyros are just doing all my fine work for me. Okay, here we go. Now watch, it'll probably start to wing rock as I get up there.
Like that.
See that?
Yeah.
Okay, so right when I start to stall out, I need the gyro to stabilize, and the plane just starts to slip away.
It's wiggling.
Yeah, it's... Whoa.
Don't come this way.
Okay. Okay, the real test now is going to be landing. Gosh, I'm shaking trying to fly this thing.
The turns are more exaggerated too.
Yeah.
They don't. You can't
Okay,
turn
here we
so
go.
tight.
Whoa, it's already popping up. Down elevator. Oh, this is going to be messy. I got to come around again. So see what I mean? It's tail heavy, so it wants to pop its nose up and stall. Those gyros will keep my nose down for me.
Okay, for real this
Yeah,
time.
it's just like floating up. Okay. Come on. Oh, dang it! Oh my gosh. It's all right.
Yay!
Okay, see what I mean? How the gyros work? I was flying it the other day and Keith came out and he's like, wow, look how smooth and straight it is. I'm like, no, that's the gyros. Yeah, but the plane, it's so smooth and straight. I'm like, no, that's the gyros. He's like, the plane is real smooth and straight. I'm like, yeah. But it works. Successful project. All right, I plugged the gyros back in. What the?
Uh-oh. What does that go to?
What a difference. Look at that. See, I can put the controller down and go get a sandwich.
Can you get me one too? Okay, do another one. Nice.
Uh-oh. The wind's going the other way.
Duh.
As I know it's coming down to crash, I'm like going to 0 throttle, then putting all my switches back so I'm not like jamming the canards into the ground. So it's like I have like all this pre-crash setting, like, oh, gonna crash, power down, put the switches back to 0, crash.
And then,
Look how easy that is. See how easy that was? I was looking the other way, I wasn't even flying it. If you're building foamies like this and doing scratch building and stuff, I get all my stuff at Grayson Hobby. There's a link over here on the YouTube. It's where I get all the motors and servos and stuff. Now again, the Metal Gear servos are what I really like. I'm really trying to convince guys to try them because you can buy Metal Gear servos and they're not gonna strip out and break. I mean, these little rough landings I'd have right now, I would have stripped out quite a few sets of carbonite or nylon gears. Metal gears are the way to go.
duh. Can I get a sandwich now?